so before I begin with the presentation, I would like to thank the entire team of JCON 2021 for giving me this opportunity to present my talk. So thank you so much. So the topic for today is basically demystifying the Java flight recorder API. So here I'm going to talk about, first of all, what exactly is the Java flight recorder API and how does one actually go about starting using it. So before I come to the main topic, a brief background about me. So my name is Karan, and I've been working primarily as an Android mobile developer for the past 5+ years now. And I have been working primarily on the B2C and B2B based mobile applications. I've also been working on technologies like AI, AR, and VR. And apart from being, I would say, passionate about technology, I also love writing poems, traveling to different places across the globe and meeting new people. So that's about me in a nutshell. Now, we all of or most of us who are not familiar with the Java Flight Recorder API, for them, I would like to have a short background. So the Java Flight Recorder API was basically an event recorder that was first integrated into the Java virtual machine. And the reason of introducing the Java flight recorder was mainly to do certain tasks like profiling, or even you can say black box analysis or garbage collection. So mainly in terms of monitoring the events that would happen in the JVM. So the JDK flight recorder was mainly introduced to do certain activities. Once it was introduced, it was later open source. So it was open sourced in the year 2018, where people started using the Java Flight Recorder API. The APIs actually came into existence. And one of the key, key points or key highlights of this Java Flight Recorder is that it is said that it has almost no performance overhead. So there is a short, thing that I would like to highlight here as well. So under default settings, so if you try to operate or use a Java flight recorder, say under default settings, so in this case using the standard recording, the standard profiling that is available, in that case it is based on the test or based on the feedback that has been given by customers. It is said that it gives you less than say 2% or 1% overhead. But if you had to use the Java Flight Recorder API for say certain applications which are slowly running, or those applications which are not ideal for production environments, then is where there is slightly high performance overhead. So that maybe would be the difference in terms of the performance overhead part. But in case of a default setting, it is said to have almost negligible or almost less than 1% of performance overhead. And one of the key features of the Java flight recorder is also the visualization of the flight recording. So that can be done using the Java mission control. So what exactly is the Java mission control? Now, Java mission control, I think most of you might have used it or might have also experienced it, is basically a graphical user interface that one can use to visualize the flight recording. So in this case, you can take this example where I have a simple JFR file. So it's an input that I will provide to the Java mission control. And once this file has been read by the Java mission control, it will help me analyze the file. So it can point out the CPU usage, the heap usage, and all those things. And it would represent it in a more graphical, graphical user interface, using a graphical user interface, so that I can quickly analyze what are the events that are taking a lot of memory, or what are the impacts of the performance in my application. So this is something that I think most of us have may or may not have used in the past, but it's really a tool that I think most of us would be using, especially in terms of performance monitoring. So one more point is that this tool also has been open source. So there is a link that I have put down in the slide, which basically talks about the open source version of the Java Machine Control as well. So one could actually try it out if needed. So coming to the topic of today, which is basically how one can actually start or get started using the Java flight recorder. Now, there are basically two ways or two approaches that I would like to discuss by which you can start the Java or run the Java flight recorder. So one is using the command line approach. Now, in this case, one can actually leverage the JCMD tool, which is included as a part of the Java installation directory. So it comes shipped with the Java installation that happens. And one can use this command to basically run a particular, or you can say start a particular recording. So in this case, one could use this command. So I have put it down where you can specify the command like jcmd followed by the process ID followed by a syntax called as JFR start, which denotes the start of the recording. You specify a duration, so in this case say 60 seconds, and you also specify a file name. So in this case, all your recordings would be basically stored into a particular file. So this command would basically start the recording, and it would go on for say 60 seconds and then store the recording into a file which you have provided. Now this is just one of the ways of starting the recording, but in there is also another way by which you can do that, and that is the second approach, which uses a Java program or an agent. So in this case, I would say that one could use the Java Flight Recorder API, by which you can use a particular command. And in this case, I have used the command Java -xx start flight recording. Now here I would like to highlight is that the Java Flight Recorder is basically not available, because it's a commercial feature. It is only available for a production environment. So if you had to basically use the Java Flight Recorder API in a development environment, you need to basically unlock it. So by default it is not enabled. So in order to unlock the feature of the Java Flight Recorder, you need to basically provide an optional and a parameter saying that unlock commercial features, and then specify the same kind of information that you provided in the above command, where you specify the duration, in this case again 60 seconds, and the file name. So the difference in this kind of an approach is that using a Java Flight Recorder API, you can actually you can create your own programs, and you can use the Java Flight Recorder API to even do the recording. So let's take a quick pause here, and let me show you a quick example of how one can actually use this to run. So I have, in the interest of time, I have done a recording of one of my projects in which I have basically used a Java Flight Recorder. So let me try running this for you. So in this case, you can see that I have a program which is using the flight recorder. It is a simple class which extends the event class. So this is basically one of the classes defined as a part of the JFR API. Now, if I had to run this application, I would run it normally using either the command line or using the code editor itself. So in this case, I have used Eclipse. So once you run this particular command, it would start the recording. So this would basically indicate that the recording has started. And once that has started, it would create a recording file for you. So it will create a JFR file that you can actually use, or you can use this command to actually check the contents of the recording. So here is where you can type in the command and then view the contents of the recording to see that whatever you have recorded has indeed been captured. So here I'll just pause. So if you can see, there is a message that I had logged into using the API, which is saying like hello flight recorder. So this kind of event or this kind of message has been captured. So how this is done is also something that I'll be explaining. Now, coming back to the presentation, we saw that we were able to use the Java Flight Recorder to start a particular program and to run the program, which basically uses the Java API. So now, what is the output of this? So the output of this basically is something called as a JFR file or a flight recording file. So before we go to that, we also need to understand what are the different annotations that I had mentioned. So whenever I create a class, I basically use some annotations. Like I use some annotations to determine what would be the event name, what would be the label of the event. So these are basically some metadata about the event so that you could track them later on. So for this example, it may be a little trivial, but especially if you're working on software projects which are having a lot of events that need to be captured. So this kind of metadata information can be provided for better tracking. And the main thing is the event.begin and the event.commit statements, which basically denote to start recording the event. And so begin with basically start recording, and commit on the other end would basically end the recording as well as write it into a particular file. So commit is basically implicitly doing both the things. So where it stops the recording as well as it writes it to a file. So that is basically the use of the begin and the commit statements. And you can see that I've also provided a message saying hello flight recorder. So this is basically going to be your parameter or the event, the log that you would like to capture as a part of the event. So I mentioned about the metadata of the event. So yes, there are some metadata that you could capture. So be it name, description, or label. One can also leverage another metadata annotation, which is basically called category, which helps you to associate one or more categories with an event, especially if you are running different events at different point of time. And one can actually specify more than one category using a comma separated list. So that is also something that one can use with the annotations that is provided. So I spoke about the output of that program. So the output of the program was basically a JFR file. Now, how do I actually view the content of that? So for that, we have something called as a JFR tool, which is also something that is provided, and it's a part of the JDK. And it basically is a tool for interacting with the JFR file. So basically the purpose of using the JFR tool is to summarize, or I would say output the recording files into a more human readable format, so that people can understand, what are the events that have been captured. And then you can, based on that events which have been captured, do some kind of an analysis. So that is also something that one can actually do based on the output that has been provided from the JFR tool. So that is the reason of using the JFR tool. Now coming to the next part, so here was a command that I actually tried running. So the command is basically called as JFR print. So this command would basically take a parameter saying the name of the class, followed by the name of the recording file. So in this case, I've mentioned that fully qualified the name of my class and as well as the name of my recording file. And this would give me an output stating the start time, the duration, the message of that, and as well as the stack trace. So in case of any any kind of errors or issues, I can easily track down the stack trace and find out the issue that has been occurred at that point. So this kind of this kind of human readable I would say format would help me to understand what exactly, or pinpoint the area where the issue has actually occurred. So this is basically a simple example of how to get started, first of all, using the Java flight recorder and the Java JFR tool. So that is basically a small introduction. Now coming to a more, I would say a more complex example, but before that, let's try to understand why should we actually use the Java Flight Recorder API, right? So that what is the reason? So normally as developers, as software developers, whenever we deploy a solution and it goes to production, there are quite a number of times when, once the app is deployed into production and an issue occurs, we try to identify the root cause. And logging, I would say, is logging actually one of the most effective strategies out there. So if you had to basically log, or you have to basically find out or trace the issue in, especially in a production environment. So in that case, how does actually one go about managing the logging part? So the logging mechanism is something that we need to think about, especially whenever the application moves to a production environment. And especially in terms of logging, we also have to take care of a number of factors, whether be it the size of the log files, the amount of log files that gets generated, and the backup of those. So all those needs to be taken into consideration. And the main question here is that, is it actually really safe to debug in production? So of course, this question is something that one can think about, and whether it's actually safe to do something in a production environment where that even the slightest of mistakes could break something. So how does actually one tackle this situation, and how does actually one come to terms with identifying the particular issue? So here is where the Java Flight Recorder can be useful. So the Java Flight Recorder API, before the Java Flight Recorder API, there was something called as the Java util logging. Now this has been there ever since the JDK 1.6. Now there is a saying that the Java util logging has actually reached the end of the road. So most of the frameworks out there, especially in terms of logging, they are all based upon the logging framework, but then each of them have their own implementation. So one of the key limitations of the Java util logging is that its inability to have a per web application login. Now in case of application servers like even like Apache Tomcat, where they have their own implementation of the login, so they do not even actually use the standard login, so they have their own implementation. So there is of course some limitations that have come across or have been known, and then because of which one actually has to go about a customized approach. So there is always something of some limitations that one has to deal with, especially when using the Java util login. And moreover, the lack of a buffered handler is also something that has a significant impact, especially on the logging performance aspect. And one of the key, I would say, disadvantages of the Java util login is that it doesn't provide, the information about the context in which the event actually occurs. So this is again one of the disadvantages, especially in terms of the Java util login. So taking into account all this, one should actually think about how one can differentiate between the Java flight recorder and the Java util login. So the Java flight recorder, yes, it does provide contextual information about the event. So you can use the event metadata, which I mentioned before, to to provide more information about the events. Whereas in case of a Java util login, the loggers basically are the only mechanisms by which you can capture events, and then based on whether you are doing a file operation, so you can use a file appender or those kind of things. So that is the only thing that you could actually do. So there is no additional information that you could capture. The Java flight recorder, yes, it does require a commercial license to be used on a production environment, whereas the Java util login does not require any such kind of license. But on the other hand, the Java flight recorder, the recording files can be visualized, so you can visualize them using the Java mission control or any other tool for better analysis. Whereas in this case, there is no built-in visualization support. The customization of events is, although it's possible in both cases, so you can customize your events in both the cases. But when it comes to saving of time and saving of better identification of issues from a long-term perspective, I would say yes, Java flight recorder could help, although it does take some amount of time to set it up in the beginning, but eventually in the long run it would definitely be useful. On the other hand, the Java util login, requires very less setup time, so one can easily get started using it. So, there is no there is no difficulty in the setup time, but of course, over the long run, it might not prove to be as useful as one may expect it to be. So that were the key differences between the JFR and the JUL. So now let's take basically a complex use case. So I mentioned about the Java flight recorder API and how it can be used. So let's take a simple example. So let's say we want to identify a slow running SQL query in our project. So let's take this example. So this example is a very basic example where you can see that there is an inner join being done on two tables. So there is a product table that I have, and there is a sales order detail table. Now the problem with this kind of a query is that the join operation, of course, would basically do a scan on both the tables. So there will be a full table scan, and assuming that the columns or the tables are indexed, in even in this case there will be a performance overhead, of course, because there is an or condition that we have in this case, and there will be if there are a lot of number of rows in both the tables, definitely there will be some sort of performance overhead. Now if I had to replace this query with something like this, so this would be the output, or this would be a better approach, I would say. So in this case, the inner join is still there, but then you have replaced the or with a union, and the union basically helps to remove the duplicate. So it basically concatenates the results and removes the duplicate. So in this case, I would say that a better approach of using or performing the same operation would be basically to modify the query in this way. But then how does actually one determine this? So this could not come so easily, right? So this one could actually have to try and try a lot of combinations to actually achieve this kind of a result, or a better optimization of the query. So here is where although this approach would be a suited one, but then the Java flight recorder API has to basically help us to identify this kind of approach. So here is where we can use it. So here's an example that I had actually come up with. So I have used a Java flight recorder API to do certain trivial operations on a database. So let's say I have to basically insert some records. So let's say I have to insert, say, 15K records into a table. So in this case, I have basically used the Java flight recorder API to capture these events. So based on my observation, the time it took for inserting these records were around 45.9 seconds. So on the other hand, if I had to basically fetch and fetch a particular record, assuming there are two cases here. So if the record is existing or if a record is not existing. So based on that, this was a time that I captured. So it was like 59.2 milliseconds for fetching a particular record which is existing, and against 109 milliseconds for fetching a particular record which is not existing. So these are basically two scenarios, I would say, which I had basically tried out in my project to identify which kind of a mechanism, or what was the feedback in terms of the performance, especially when you're doing some basic operations. And here is where you could actually identify what is actually going wrong and why exactly it is taking so much time. So the here is where you will have to go back maybe in terms of the optimization on the query side, or you could actually try to even deep dive to understand what exactly is happening at the database level as well. So here is this could actually help you to at least reach a particular conclusion based on your use case. So this is one example that also I wanted to highlight, where you can use a Java flight recorder. Now, coming to the next part, so the Java flight recorder, one can imagine it to just capture, say, events, but then it's not just events that can happen or that can be captured. You can actually do a lot of more things using the Java flight recorder API. And there are a lot of things like, for example, custom annotations, dynamic events, periodic events. But I'm basically, going to be focused on the event streaming API. So the event streaming API also is, something that I was particularly interested also. And here is something about the event streaming API. Now, in general, the event streaming API is basically used to create certain custom events to monitor certain HTTP calls on the network. So assuming you are basically using a lot of APIs, and you need to monitor a certain network traffic or monitor the HTTP calls, how many calls have been there, like what are the parameters, etc. So that kind of information also the event recorder can capture. So here is an example where you could create your own class which extends the event class, the base class, and you could define a name for your event. So in this case, you could give it a name, and you can define some metadata. So in this case, I would basically be capturing certain query parameters. So I have labeled it accordingly. So once this is done, you can actually create, the next step would be, of course, to create an endpoint. So you need to have an endpoint, a RESTful or any API endpoint that you could create. And that particular, inside that particular endpoint is where you could actually create an instance of that particular custom class, and then call the begin and the commit methods to start the recording. So what will happen is that whenever the particular endpoint has been invoked through basically the application or the web app or the any client app which basically invokes this particular endpoint, would basically trigger the recording to start. And this would basically happen, and the recording file would be then generated. So then this kind of an approach would help you to find out in case of, especially in terms of APIs which are slowly running, or there's a lot of operations happening at the database or the network level. So that can be identified in this kind of this kind of an event as well. So this is one of the examples by which event streaming, the API event streaming, can be used. So basically what one needs to do is that one needs to actually subscribe to those events in order to basically know what is happening. So for that, basically you can use the event stream class. So the event stream class is something that is also part of the the API, where you can use the event stream to open the repository path and then subscribe using an on event method. And here is where you need to provide the name of the event, and then specify maybe a condition saying that, okay, if there is an event which is taking, say, more than 2500 seconds or something milliseconds, so in that case you do something over there, so you take some particular action. So this is basically an example. It could vary based on the use case that you're trying to develop. So this kind of a mechanism also helps you to identify those APIs or those HTTP calls that have been that have been taking more time, or that are basically causing a performance bottleneck. So this is about the event streaming API in general. So I mentioned about how the event streaming. Okay, so I mentioned about how the event streaming API would be created, and one could actually start that once the event streaming API has been used and the classes have been created, one can actually run the application using a simple, like in this case, if you're using Spring Boot, you can actually run it using a simple command that I've mentioned below, that you can mention the Java -XX start flight recording and specify the target, or the target to the destination to your jar file, which would basically start up the server and eventually start the recording. So that is basically how one can actually go about using the event streaming API and using Spring Boot as one of the servers for hosting the API itself. So that's about it from the event streaming perspective. So what I have done is that I have actually put down all the sample code, the deck and the demo videos on these links. So please feel free to to have a look at them and try to customize them as per your requirements. So I have basically mentioned all the links, and a note is that I have actually tested and compiled this using the Java JDK 16. So this is using JDK 16 primarily. And yes, so please feel free to have a look at these links and try to customize or provide your feedback as and when possible. So, so the conclusion of this particular talk is that yes, so using the Java Flight Recorder API is something that one could debate about, and whether one could actually use it in a production environment is something that the debate is still ongoing. But then if I had to choose between, say, a conventional logging framework and a Java Flight Recorder, there is where in terms of a long run, I would say that the Java Flight Recorder does have the capabilities, and maybe going forward it would it would provide many more such functionalities by which performance monitoring can be made easier at the production environment level. And it is up to us basically to choose the right approach, of course, but then one could always try your hands out at a new a new mechanism as well. So these were a couple of references based on which I compiled my presentation today. So thank you so much once again to the entire team of JCON 2021. Please feel free to ask any questions or any feedback. So I can take it now. Thank you. Okay. Okay, so there is a question, would I include the custom event and the REST endpoint in my application? Not necessarily. You can have maybe the REST endpoint could be a part of your Spring Boot project, and then you could have maybe a solution or a different project or a simple a jar basically that would embed, and that would basically trigger the event. So there could be multiple approaches. You could include it, yes, as a part of the same project, or you could have a different project as well. So that depends on how how the requirement is. So I hope I answered that question. Okay. Okay, so so maybe I have done the same thing. So maybe you could have a look at the sample code that I'll be sharing. So I think that would help all you to basically get started with your custom event and endpoint. Okay. Any more questions? Okay, so if there are no questions, so we could maybe end the presentation. Are there any questions, anyone? Okay, so yes, so where would the event subscription code run? The event subscription code run would be basically your agent. So you will have to listen. So assuming you have that APIs exposed using, say, a separate application that you have developed. So these APIs would be running anyways, but then you would need to have an agent. So that agent would be would be running in the background, and that agent would be subscribing to those events that you would be defining in your original Spring Boot project. So there has to be kind of an agent that has to be running in the background to subscribe those events. Okay. Okay, so I think if we have no questions, we could wind up. So once again, I would be sharing the link to all the slides and the code and the videos as well. So please feel free to go through them and try to extend it to your particular requirement as well. So, and if any issues, please let me know as well. Okay, so thank you so much, and enjoy the rest of the event.